Hello friends, welcome to Shiksharthi. In this video, we shall be discussing Orthocenter under the head of geometry. So let's start. Now, at the very outset, we need to understand what is an orthocenter. So orthocenter is the point of intersection of the altitudes which are drawn inside the circle, inside the triangle. For example, how many altitudes can I draw inside a triangle which is not a right angle triangle? So the maximum number of altitudes which can be drawn inside a triangle which is not a right angle triangle are 3. If it is a right angle triangle, then what are the maximum number of altitudes that you can draw inside a right angle triangle? There is only one altitude that you can draw. Okay, so orthocenter again is the point of intersection of the 3 altitudes which are drawn inside a non-right angle triangle. Okay, having said this, this incidentally happens to be the third geometric center that we are talking about. So we have already talked about median, we have already talked about end center, now we are talking about orthocenter, and the last that we'll be talking about in the next video would be the circumcenter. So this being the third geometric center. Okay, so I have taken a triangle ABC such that I have drawn 3 altitudes inside this triangle, and at the same time I have divided the angles. And for example, the only thing that is given in this triangle is information number 1. So this is the information which is already given. So what are we trying to say? We are trying to say angle BEA is the same as angle BEC is the same as angle BDA is the same as angle CDA is the same as angle CFB is the same as the angle CFA, and all of these are equal to 90 degrees. Henceforth, when I start assuming values to the vertex, for example, I have taken this, I have taken the angle OBD as X. So in that case, this is already 90, which is already known to us. So this becomes 90 minus X, and then we can experience the property of vertically opposite angles here. So along with the concept of altitudes, we can apply the concept of vertically opposite angles being equal. Okay, so which is what we have discussed in point number 2. Point number 3, now since we have already divided the vertex angles, and you will see how many angles have we divided this into. So 6 of these, another 2, another 2, another 2, 6 of these, and another 3. So basically how many angles? Somewhere around 15 internal angles dependent on the triangles which have been formed inside a triangle. So again, from here, can I say that now here, if I talk about the triangle BOD, can I say triangle BOD is similar to triangle AOE? So BOD is similar to triangle AOE. Yes. And the same thing I can say for triangle AOF. So triangle AOF, we are talking about Y, 90 minus Y and 90, is similar to the triangle COD. COD. Yes. And finally we can say FOB. So FOB is this, is similar to the triangle COE. Let's see whether this is correct or not. These two are correct. So just to practice similarity. So if I am saying FOB, in that case I am basically talking about 90 degrees, 90 minus Z and Z. And in COE I am basically talking about Z, 90 minus Z and 90. So I should basically say what? EOC. So this becomes EOC, not COE. Right? So, okay, a small correction here. At the same time, we have taken this as a scalene triangle. Now we know that for a scalene triangle, the 3 sides, the length of the sides. For example, I have taken the length of the side AB as C, length of the side BC as A, the length of the side AC as B. So we will say A is not equal to B is not equal to C. At the same time, if I am interested in finding out the angle BOC, we know that this is equal to 180 minus x plus y, which is just like saying angle BOC is nothing but 180 minus the immediate vertex angle, which is angle A, which can also be understood as 90 degrees plus Z. Once you are able to substitute this value, because we know that this equation, from where do we get? We get this from the summation of all the interior angles of a triangle is equal to 180 degrees. Thereafter, you will be able to say twice of x plus twice of y plus twice of z is equal to 180 degrees. Henceforth, x plus y plus z becomes equal to 90 degrees. Okay. The next point, which is point number 6 that we are discussing here, is, can I say the area of this entire triangle is nothing but the summation of basically 3 areas. So the 3 areas are triangle BOC plus the area. So if I talk about the triangle, the area of the triangle BOC plus the area of the triangle AOC plus the area of the triangle AOB, I get the area of the triangle ABC. So what is the area of the triangle BOC? Is half into base. Now base is A into height, which is OD. Plus, now what is the area for this triangle? Half into base. Base is B. What is the height? OE. And the last, the area of this triangle is half into C into OF. This is equal to the entire area. The next point, which is equally important here, is, can I say the area of the triangle ABC can be written in terms of, because altitude is nothing but the perpendicular drawn on a side. So the area of this entire triangle, if I view it from this angle, this side means I'm talking about triangle ABC, is nothing but half into base, which is BC, into height. If I look at it like this, where B is the vertex angle, I can say half into AC into BE. And at the same time, if I look at it like this, where C is my vertex angle, I can say the area of the same triangle is nothing but half into AB into FC. And thereafter, I can play some interesting games here. So what is the interesting game that you can play here? Now you can deduce some formulas of trigonometry from here. So for example, if I want to pick up this, I can say this area can be written in terms of half into BC, and AD becomes AB sine x plus z. So x plus z is this. So AD upon AB becomes sine B. And the same thing you can do for others. So the last but not the least is the byproduct of this entire discussion that has taken place here, from where we can establish the sine rule. What is the sine rule? The sine rule, you can establish it from here only. So we know that all these 3 equations are equal to one another. So divide all the 3 equations by AB into AC into BC. Divide all 3 of them. So when you're dividing it by all 3 of them, the product of the 3 sides, this you can write it as sine of x plus z divided by AC. Now what is sine of x plus z? Sine B. So sine B upon AC, and the same thing you'll do for others also. So you can write it down as sine B upon AC is equal to sine A upon BC is equal to sine C upon AB. A very important deduction, because if you recollect, in my last video I talked about geometry is very important for geometry itself, then coordinate geometry followed by trigonometry. It's very, very important. Most of the deductions in trigonometry, you can just do it just with the help of some of the byproducts. These are some byproducts. Okay, now finally we'll be talking about, had this triangle been an isosceles triangle. So in that case, what would you say? So the piece of information that is already given here is this triangle is an isosceles triangle, and we have assumed here that we are trying to make it as an isosceles triangle, assuming that angle B is equal to angle C. So the moment we say angle B is equal to angle C, we'll be able to say that the length of the side AB, or the length of the line segment AB, is equal to the length of the line segment AC, which is these 2 sides. And thereafter we can establish that x becomes equal to y. So the moment x becomes equal to y, we have just substituted the values here. So this becomes y, this is already z, this becomes y, this was already z, and these 2 become y. So we know that this entire triangle is an isosceles triangle. Inside this, when I am getting these 2 triangles, even you need to see that this is not only a perpendicular, but it acts as a perpendicular bisector, which we have talked about. We have talked about this point earlier also in one of my videos. But here you can prove it now. So once you are able to segregate it in terms of the angles, which we have already done now, The second thing that we can talk about is, can we say that AOF, the triangle AOF, this point is O, and triangle AOE, they have a side in common and they have at least two angles same. So can we say that they are congruent? Yes, they are. The moment you say that they are congruent, you can establish something here. And what is the thing that you can establish here? You can say that these two sides are equal and even these two sides would be equal. This is what you can establish. Once you have established this, now it is the time for these two triangles. So can I say these two triangles are congruent? Yes, they have at least two angles equal and this is the common side. So you can apply any property of congruency, which is either SAS, or you can apply you can apply ASA, right, or any other property and prove that these two are congruent. So can we say triangle BOD and triangle COD are congruent to each other? Yes. The moment you are able to establish this, you will be able to say that BD becomes equal to DC. At the same time, BO becomes equal to CO. Now it is the time for these two triangles. So which two triangles are we talking about? We are talking about triangle BOF and the triangle COE. They are definitely similar to each other because we can apply AA test and we know that congruency starts from similarity. So we can definitely say that they are similar. Now it is the time to establish that they are not merely similar, they are congruent as well. For that, you just need to have what? Either I can apply AAS or any other property, SAS or ASA or whatever, and you will be able to prove that even these two are congruent. The moment you say that these two are congruent, we'll be able to say that even these two sides would become equal, right? Then thereafter you can establish some facts. For example, if I want to find out the length of AD, I can always apply Pythagoras Theorem. And when I apply Pythagoras Theorem, I know that AD is nothing but under root of hypotenuse square minus the base square. Now hypotenuse as it is, we have assumed it to be B. So this becomes B square minus, and how much is this? If I have taken this as A, in that case this becomes A by 2 and this becomes A by 2. Right? So B square minus A by 2 whole square. This is the length of AD. Now we know that the length of AD is not the same as the length of the other two altitudes. Why? You can prove it yourself. We have discussed it earlier also, but here also you can prove it for yourself. Okay. So now, but can we say that the length of BE is equal to the length of CF? Of course you can, because you know that these two parts are equal and so are these two parts. So when you add them, the entire length becomes equal. So we can say that in an isosceles triangle, this this AD, which is nothing but perpendicular, an altitude on the side BC, is not merely an altitude, it is a median as well, and it can be called as a perpendicular side bisector. But you can't say the same for other perpendiculars, because the other perpendiculars, if I talk about BE and CF, they are merely perpendiculars or altitudes, they are not the medians. Because had they been the medians, in that case these two would have been equal, which they are not. So can we find out the length of BE? Okay, where is BE? So I can either do it from this side or I can find out the length from this side. So if I want to find out the length from this side, I know this is hypotenuse. How much is the hypotenuse here? C. So this is hypotenuse square minus this. Now what is this? This length we don't know. So if this is x, in that case this becomes how much? B minus x. This is all we know. So we can say this is nothing but c square minus x square, or we can find it from the other side. The other side is, this is common to both these right angle triangles. So from this side I can say that it is nothing but hypotenuse square, which is a square minus b minus x whole square. So from here you can get the values of x in terms of ABC, if ABC would have been known to you. Finally, can we talk about the triangles AOF and BOD? Now why are we talking about these two triangles? Because we see that all the interior angles of these two triangles are the same. So can we say, are they similar? Yes, they are. But what is your homework now? Your homework is, similarity is a stepping stone for congruency. So prove whether they are congruent or not. You already know that they are similar, but prove whether these two triangles are congruent or not. This will help you to practice. At the same time, as a special case, if I draw a scalene triangle, which is a right angle scalene triangle, I can draw a right angle isosceles triangle also. I can draw both. In that case, the orthocenter would always lie here. I repeat, in a right angle triangle, whether I have these two sides as equal or I have a scalene right angle triangle, in either of the cases, the orthocenter would always lie on one of the vertex, and that is the perpendicular vertex. The vertex which forms an angle of 90 degrees. How? You know it because what is an orthocenter? Orthocenter is the point of intersection of the altitudes. And as we discussed earlier, in a right angle triangle, we can have maximum one altitude lying inside a right angle triangle. Right? I hope you would have learned something great today. I hope. The more you practice, the more you would learn. So as suggested, please take theorems as questions. Start doing all these questions so that once you start doing real questions, you can apply theorems in them, because it will not come to you as a surprise. So if you feel that something really informative has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you can start receiving updates from us regularly. If you want us to do some specific topics, some specific videos on specific topics, please put it in the comment section. Thank you so much. Until next we meet, goodbye.